Good day, everyone. This is Gifted Brain, and today we shall be considering DC circuit theorem. Under this, we shall consider introduction to direct current circuits and definition of term used in direct current circuits.
Circuit theory. Well, this connotes all theories that are used in obtaining parameters and majorly current and voltages across the elements in a circuit. Now, we shall be considering theories for direct current circuit, DC circuit. There are so many of these theorems, but we shall be considering the following. 1. Kirchhoff law. 2. Mesh analysis. 3. Node analysis. Superposition theorem. Thevenin theorem. And Norton theorem. So now we want to consider important terms used in circuit theorem. Terms would often come to meet, so we have a clear understanding of what we are doing. Well, first and foremost, we have circuit. This is a closed conducting path through which current either flows or is intended to flow. That's a circuit. Again, we have also number 2, circuit elements. This could be voltage source, could be current source, or even resistor, etc. And now we have a node. This is a junction in an electric circuit where 2 or more circuit elements meet. And so we look at other terms actually, and I will be illustrating what a node is, what a branch is, and on and on. Next is the branch. This is that part of a circuit that lies between 2 nodes. Then a loop. This is a closed part in an electric circuit in which no element or node is encountered twice. Then we have mesh. This is a loop that contains no other loop inside it. Now let's begin to illustrate all of this now. You see, this is a node. This is a node. This is a node. Now, how do I know the nodes? This is a circuit element. This is a resistor. You connect a wire here. You connect a wire here to a resistor. This is a cell. A wire to this part of the cell, and that wire to this part of the cell. Now, if you join these two together now, where you join it together becomes a node. So, this is a node. The wire of this cell and the wire of this resistor connected here. That's a node. The wire of this resistor, the wire of this resistor, the wire of this resistor. These three, they meet here. This is a node. So, A is a node, B is a node, E is a node. Please, F is not a node. So, a node is a junction in an circuit where 2 or more circuit elements meet. Where you hold them together, where you tie them together, that's a node. So understand that F is not a node. Why? Because the second wire of this cell actually, and the second wire of this one ought to meet here. So this thing can be redrawn actually, to be drawn like this. So this becomes the node. I'm only drawing this thing like this to make it look fine or fanciful, not because F is a node. So F is not a node. Understand that this is not a node. Why? Because the second wire of this can just simply be connected like this. So this is where the node lies. The wire of this, second wire of this, and the wire of this, they all meet here. That's the node. So understand now, it is drawn like this, C to D, and then D to E, just for neatness, for it to look neat. So understand, A is a node, B is a node, E is a node. The node A is not often referred to, or we don't reference it, but the B and E are often referenced. So that's that about a node. Now a branch lies between 2 nodes. Now take note now that from here, B, C, D, E is a branch. This is a branch. From here to here is a branch, and from here to here, that is B, A, F, E is a branch. So this is a branch, this is a branch, and this is a branch. Now, remember it says a branch lies between two nodes. This part starts with this node and ends with this node. That's why it's a branch. This whole part, this B, C, D, E, starts with B, a node, and end with B. So all this B, C, D, E lies between node B and E. That's what the definition is trying to say. It lies between two nodes. Again, this part lies between B and E. Some will say, what about A? Well, like I said, it's not all often referenced. So we majorly take B and ignore A as the node. Like I said, it's not often referenced. So the node here will be as though we're not seeing A as a node. B down to E. And there's a reason why we may not be seeing A as a node. When we proceed, I would explain that why we don't majorly consider A. So that's about that. That's a branch. So this circuit now has three branches. 1, 2, and then 3. And each of those branches has a current flowing through them. Again, we have what we call a loop. What's a loop? It's a closed part in an electric circuit which no element or node is encountered twice. So this, let me show you what a loop is. A, B, E, F, back to A is a loop. B, C, D, E, B is a loop and also a mesh. So this A, B, E, F, A, just going around this once, is a branch and a loop. You must not encounter any circuit element twice. Mean that if I go like this, I've encountered R1. Nothing should make me come to encounter R1 the second time. So take note of that. So if you start from here, you should come back and end here. Don't pass through that node two times. That's what it simply means. That's a loop and a mesh. So A, B, E, F, A is called a loop and a mesh. B, C, D, E, B is called a loop and also a mesh. But there's another loop here that cannot be called a mesh. Let me show that. That can be seen here now. Pay attention now. We have A, C, D, F, A. A, C, let me put the resistors. R1, then we have the cell here. Sorry, we have this resistor here. And then that's all. A, C, D, F, A. Now, if you look at this A, C, D, F, A now, it's like the bigger loop that contains this small A, B, E, F, A, B, E, F, A, and B, C, D, E, B inside it. This one here now can only be called a loop, but cannot be called a mesh. And that's because a loop may contain smaller meshes inside. This loop contains smaller loops inside or smaller mesh inside. But whatever you call a mesh, like A, B, E, F, A, if you call it a mesh, that's because it cannot contain smaller ones inside. But a loop might contain or may not contain. So that's what we're trying to say here, that a mesh, this is a loop that contains no other loop inside. But for a loop, it might contain smaller loops inside or not. So otherwise, a loop is actually a mesh. Just that a mesh cannot contain other smaller mesh inside, while a loop can contain smaller meshes inside it. So that's that about these terminologies. So the next thing we're considering now is Kirchhoff law.